Hello बच्चों, let's read this question. Question says a sample of argon gas at 1 atmospheric pressure and 27 degree centigrade expands reversibly and adiabatically from 1.25 decimeter cube to 2.50 decimeter cube. Calculate the enthalpy change in this process. CVM for argon is 12.48 joule per Kelvin per mole. So here in this, what is a given data? Given data is pressure, that is equals to 1 atm, and temperature T1, it is equals to 27 degree centigrade, which is equals to 300 Kelvin. Now the volume V1, this is equals to 1.25 decimeter cube, and V2 is equals to 2.50 decimeter cube. Also CV value is given, CVM, that is molar heat capacity at constant volume, it is equals to 12.48 joule per Kelvin per mole. Now we have to calculate change in enthalpy, and change in enthalpy represent as del H. So we can write our key concept. Key concept. So what is the key concept? We have to find out the change in enthalpy. So change in enthalpy is equals to N CPM dt. So here N is equals to number of moles, CPM is molar heat capacity at constant pressure, and dt is equals to change in temperature. We have temperature T1, so we have to find out temperature T2 and also number of moles. So we can calculate firstly number of moles. Number of moles. So we can use ideal gas equation. Ideal gas equation, and for calculation of second point, that is temperature T2, we will use Poisson's equation. Poisson's equation. Okay, now we can put the values in these equations. So ideal gas equation, that is PV is equals to nRT. We have to calculate number of moles, so N is equals to PV divided by RT. Now the value of pressure, that is equals to 1 atm, multiply by V1, that is equals to 1.25 divided by R. R is a universal gas constant and the value of R is 0.0821, multiply by the temperature T1, that is 300. So the value of number of moles comes out to be 0.05075. Now we have to calculate temperature T2. We will use Poisson's equation. So the Poisson's equation which is used in this, that is, this is for first and this is for second. Here it is, we can write T1 V1 raised to the power gamma minus 1 is equals to T2 V2 raised to the power gamma minus 1, because TV raised to the power gamma minus 1 is equals to constant for adiabatic, because here it is given the process is reversible and adiabatic. So this is applicable on reversible and adiabatic process. So the pressure T1, here we can also write it as T1 by T2 is equals to V2 by V1 raised to the power gamma minus 1. So here the T1 is equals to 300 Kelvin divided by T2, we have to calculate, it is equals to V2, that is equals to 2.50 upon V1, that is equals to 1.25 raised to the power gamma minus 1. So here the value of CVM is given, and this is a argon, so argon is a monoatomic gas, and for this the value of gamma is equals to 1.66, because gamma is equals to Cp over Cv. This is equals to gamma. So we can write here gamma minus 1, so gamma is equals to 1.66, so 1.66 minus 1 here. So after calculation we will get the value of temperature T2, that is equals to 1.8, sorry, here it is 188.55 Kelvin, 188.55 Kelvin. In this the value of CVM is given, that means molar heat capacity at constant volume is given. So we can write here Cp is equals to CPM is equals to Cv plus R. CVM, that is molar heat capacity at constant volume, so we can write CVM plus R. Here the values are 12.48 plus 8.314. This is the value of universal gas constant. So here the value of universal gas constant is written as 8.314, and in this ideal gas it is written as 0.0821, because the units are here liter atm. that means pressure is in atm and volume is in liter, decimeter cube is in liter, and here the value of CV is given in joule, so that is why the value of R is written as 8.314. So the value of CP, that is molar heat capacity at constant pressure, comes out to be 20.794 joule per Kelvin per mole. Now we can substitute the values in the formula. So the del H, that is change in enthalpy, is equals to NCP dt. So N is number of moles, which is equals to 0.05075. So 0.05075 multiplied by the value of CPM, that is molar heat capacity at constant pressure, is equals to 20.794 multiplied by dt, that is change in temperature. So T2 is equals to 188.75. Sorry, it is here it is dt, that is T2 minus T1. So here it is equals to 188.55 minus 300, that is equals to T1. So the value of del H comes out to be, so that value of del H comes out to be 117.6 joule. So this is the value of change in enthalpy. Hope you understood it well. All the best and thank you.